In the last video, we saw how to set up a basic, very simple struct, and we also saw that we can use the dot operator to access members. We can have member variables, or in Java we used to calling it data members, and these are the parts of the struct variable. You can have different structs with the same data members, so the same member variables with the same names, and there's no conflict. You can have, if you have two structs with the same int x inside it, it's not a problem. Okay, so there's a bunch of examples in the book, and there's display 6.1 in chapter 6 looks at this account struct, and it has nice descriptive names, all the kinds of things that you want in your programs. And of course, I'm going to set up very simple structs with minimalist sort of names, with very short names, mainly because I just want to concentrate on the syntax. Okay, so take a look at this example. It's a very nice example, and it even uses functions that accept struct as parameters. In this case, just the cd account v1 struct. And so all of that is possible. We'll take a look at this. One thing you want to remember, keep in mind, a lot of people make this mistake of not putting the semicolon at the end of a struct. This is a common pitfall. And what happens is you get a whole bunch of error messages. Well, let's see what error message we would get. So let's say we forgot to put the semicolon. Eclipse is nice in that as soon as you type in the struct and the name of it and the curly braces, it puts in the closed curly brace and the semicolon. So it's kind of hard to mess up, but still possible. So there was a whole bunch of error messages. It's almost not very useful looking at them. It says error new types may not be defined in a return type, whatever that means. So it's confusing this. It's saying that it thinks that all of this belongs with this main, and so it's telling you that main has something wrong with it. In fact, all you're missing is the semicolon. So you might want to try it out just to see what error messages you would get if you do something like this. Okay, so I can set up another struct y. I can put it all in one line just to save space. So I can say int x and double y. There's no reason to do this, but this is possible. It's certainly allowed in C++. Two structs with the same names for the data members. And if you're used to writing classes, you probably know that all of this is okay. Let's compile it to make sure. But we got an error message. Oh, okay. Sorry about that. Semicolon. I forgot my semicolons because I put it all in one line. Alright, my mistake. Let's compile this. And everything works. So this is all valid. Yeah, you need semicolons. Commas won't work. As long as you have those, you're good. Okay, so try not to forget this semicolon at the end of a struct declaration. This is required since you can actually declare structure variables in this location. What does that mean? It just means that you can have something like this. So now this my y struct variable is an instance of this y struct. And so you can still have in other instances of y. For example, you can do it here. You can say y and a. That's a nice simple example. If you're not sure, you can compile it and see. You'll get a warning saying you have a variable named a, but you don't use it. But this is all perfectly fine. So this is valid Java syntax. I'm sorry, valid C++ syntax. Okay. So if you have a struct, for example, named crop yield, that's the name of the struct, you can set up two variables, apples and oranges, just like you can with ints. You can say int apples, comma oranges. That same thing is allowed with structs. Both are variables of this type, crop yield. And you can do assignment statement with structs, and we saw a simple example of that. Structs can be used as function arguments. So the example in the book has a struct that's used as a function argument, and in fact I'm going to scroll back up. Note that they use the struct, they call the struct by, and they pass it by value. I'm sorry, they pass the struct by reference. There's an ampersand here, and so you can do pass by value or pass by reference with structs. Okay, so structs can be passed as arguments to a function, just like any simple data type can be passed by value or passed by reference, or you can have two structs as function arguments. That can be a combination, one by value, one by reference. You can also return a struct from a function. The return statement in the function definition should send a struct variable back to the caller. Okay, so we looked at a very simple way of initializing structs, and now we'll see that just like with arrays, you can use the curly brace notation. So let's do that. Let's convert our simple structs to use this curly brace notation. And how does that work? You have to do it in the right order. This 10 will go into the same order that it's declared. So the 10 will go into the X. And you have to have them separated by commas. This 3.1415 will go into the double Y data member. So usually this looks a lot better than what we had before. Okay. So now we have two structs, one X, lowercase x, which has the data members 10 and 3.1415, and the other one, lowercase y, has the data members x. Data member x is set to 5, data member y is set to 2.781. Let's check and make sure all of this compiles. Sure enough, it does, and print it out, and everything is fine. So we tried this out, assigning a variable of type struct x to another variable, and all of that works. Let's take it out and just check and make sure all our initializations worked. So we should get two values now. X has 10, 3.1415, Y has 5, 2.781. Good. Everything works. Now, do note that there is strong type checking, so that if you said A has the values 1, 26.34, this will work. But even though these two structs, x and y, they're not visible right now. X has an int and a double, y has an, so does y, and y has an int and a double. You cannot do something like x is equal to a. If you try to do that, when you compile it, oops, maybe you can. No, you cannot. You get an error message. Okay, it's good to know. Strong type checking does work in C++. Even though these structs have the same data members, and technically you'd think this would be possible. No, it's not. C++. If you use two structs of different types, you just cannot assign one to another. Okay? Alright, so this is definitely not allowed. Alright. Alright, save that, compile to make sure everything works. Okay, so if you have multiple other data members, you can initialize all of them. It has to be done in the order that they are declared. So next we'll move on to classes. Of course, we'll do quite a bit with structs, just even now, now that we know that we can set up classes. But structs will still come in handy. So we'll use both. We'll use both structs and classes. I'm going to start classes in the next video.